Generative AI Examples. We're going to look at large language models for self-tutoring, and part of this is to help you review the calculus in this course. So a large language model is a multi-scale complex model. For example, if you ask it, what is E? Well, the letter E is the fifth letter in the English alphabet. This is its reply. See, we didn't tell the large language model that the context is mathematics. Now, if we go behind the scenes of ChatGPT, this is what it looks like. This is the playground. And we can set the session's large-scale context or flavor or style. Please answer mathematically. What is E? This is a first look under the hood of ChatGPT, but I'm going to use ChatGPT itself until we need this, in part because it's not free. So please answer mathematically, what is E? And this is ChatGPT's response. It looks pretty good. It's a mashup of Wikipedia articles and other sources, but it has some ambiguity even in the first sentence. You see, E is actually called Napier's constant. Euler's number is an informal, vague reference to E. Euler's constant is a different number. It's gamma, which is about 0.577. And so mixing or mashing up the articles produce some terminology that could lead to some confusion later on. See, a careful tutor would not use constant in the same sentence as Euler's number. So E is a mathematical constant known as Napier's constant. Euler's number is a vague reference. See, teaching and tutoring requires both insight and foresight, a vision and perspective of what a student will be doing later with what they're being taught now. In fact, you may be better off just using a search engine like Google directly rather than naively relying on a large language model's mashups of the same search results you might Google. See, LLMs do not think or reason. ChatGPT does not have vision or perspective. It does not ever foresee anything, certainly not what a user is going to do with the information at a later date. It's a model that has learned the importance of scale in English language communication and how to model it. It cannot teach or tutor like a human would, but it is possible to use large language models for self-tutoring once you understand the importance of scale. For example, large language models assemble information across scales. So I'm going to show you in a large sense how large language models actually operate. Suppose we give it this passage. Walking in the woods leads to danger. Cody was walking toward a mama bear with cubs. Look out, stop, turn back, yelled a man nearby. But it was too late. The bear was now chasing Cody. Now the LLM does not read or understand as I did. It parses each word into a token. Each token is mapped to a vector in RD for a very large value of D. Each sentence is mapped to a collection of tokens, a matrix of vectors. And the large language model learns the multi-scale nature of the content itself. It identifies and associates phrases look out, stop, and turn back with each other. It does not know what danger is, but it does associate danger to those phrases and perhaps also to that phrase too late. The large language model knows that Cody is walking in the woods. So what kind of information could we trust from this large language model? Well, that a mama bear with cubs running toward something could be dangerous. That look out is a phrase that implies danger is near. But the large language model may also yield nonsensical, unsupported results. Cody is a common first name for men. Cody is also a common dog's name. But Cody with a K, that is something the large language model's never seen. Could be a misspelling, or it could be just an unusual spelling of one of these names. Yet it may say that Cody is a woods, or it even might say that Cody is a danger. See, a large language model associates words and phrases across many different scales, and sometimes that's not correct. So let's look at using large language models, for example, with notebooks. A prompt is a question or statement given to a large language model to which it produces a response. A prompt has a context. The user can indicate the context within the question itself, and the response often has a format. The user can specify the format or export the result and reformat as needed. And then there are always, most often, follow-up prompts, replies to the results that the large language model returns. So here is the Anaconda distribution at the Anaconda Cloud, or you can download the Anaconda distribution and install it. Either way, you will get to the point where when you go to Jupyter Lab or Jupyter Notebook, you'll see this screen. You'll need to confirm your age and click continue so you can use the AI assistant. It's essentially ChatGPT for Python. And now you can ask it a question. We're actually going to ask it a non-Python question. In calculus, how is e related to the function e to the x? And here's its response. But notice that it didn't really know what kind of formatting you wanted. So now we're going to have to do some work. So click and export this into the notebook. And it doesn't look quite right, but we can double click on the cell. Notice we're now using our knowledge. We get the markdown code, and we realize what needs to happen is the backslash parentheses and the backslash square brackets need to be changed to dollar signs. So let's do that. We do Control F or Edit Find from the menu, and it brings this box up. We click on the little arrow, and we get the Replace box. And now we enter backslash square bracket in Find and double dollar sign in Replace. And then we click Replace All. And now all the backslash square bracket open have been replaced by dollar signs. Do this again with the backslash close square bracket and the different parentheses forms with single dollar signs. And then run the cell. So you can click on the run arrow on the toolbar, or you can do Shift Enter. And now you get this. Notice this is a nice response, one that you've done together with ChatGPT, this through the AI assistant. So when you're using large language models as assistants, for example, self-tutoring, the prompt is a question or statement given to an LLM from which it builds its response. Literally, the response is built from the prompt itself. It's a construction. And there are some initial guidelines for good prompts, not for how you talk to another person, but how you give good prompts that will give good building, good constructions from the LLM. First, describe the context, the language, the data, the library to use. Be specific within the context, no vague references. Specify what the final result should be and look like. It's okay to have a long prompt as long as the prompt satisfies these other three conditions. Specifics, smaller scales, in a context, larger scale. And then follow-up prompts often focus on a result for the initial prompt at a specific scale. For example, we in math always ask it to check its work. So with calculus as the context, define a function f of x equals exp of sine x plus cosine 2x. What is the derivative of f of x? Well, this was my prompt. It was large scale because it said calculus is the context. It had a smaller scale, specific function definition, and then across scales, I defined notation that is familiar and standard within the calculus context. And that allowed it to give me a really nice response. But don't large language models often make mistakes, have hallucinations? We've already seen ChatGPT is terrible at math. Yes, we've seen all that. So we ask it to check its work. In this case, take the antiderivative of the result. So what is the antiderivative of that derivative? And here it goes through, and it does a calculation of an antiderivative. And notice that it knows what's going on. It's trying to obtain the same result. It does this correctly, and sure enough, it worked. It's surprisingly adept at direct symbolic calculation. such as for antiderivatives. In other words, if there is a very specific set of mechanical rules for doing a problem, ChatGPT tends to be pretty good at executing those. So here we find the antiderivative of cosine of square root of x. It is done using a substitution, and you have to do some algebraic manipulation within that substitution. And once you get done, you have the antiderivative. Now ask it to differentiate and make sure it's the right answer. It's more explanatory than Wolfram Alpha, which does the same thing, but without the nice conversational explanations. It can be quite helpful in this course. So the binary cross-entropy function, for example, which we'll use quite often, is b of p is equal to negative p log p minus 1 minus p log 1 minus p, where p is between 0 and 1. How would we calculate the derivative of b of p and then simplify the result as far as possible? It's a longer prompt, but it's a good prompt. And it gives us a good result. It tells us step by step, takes the derivative of each of the terms, combines the results, and then uses laws of exponents to do a simplification. So large language models as assistants, self-tutoring, they're not appropriate to those with no knowledge of the subject. They can give very misleading, even incorrect, that seems to be true results. So you must know enough to construct good prompts, and you must know enough to assess the results. But it's highly appropriate for complex conversations based on multi-level specificity within a given context. So remember that a large language model is a model. It does not think. It works across scales to build its responses. So let's ask it something a little more involved. Our context is Laplace transforms in the variable s, as you would see, say, in calculus or differential equations. Now define the function f of t equals t to the 1/2 power. What is the Laplace transform of f of t? We gave it a good prompt. We set the context. We asked it to do something very mechanical, and it gave us a good result. So U plus large language models can do calculus. We've explored how it might assist in review and utilization of calculus in one variable. Linear algebra and large language models we'll look at in Module 3. And as code assistants in Module 2. In this course, we will see a great deal of calculus, especially with exponentials and logarithms, but nothing you and ChatGPT can handle, as long as you realize the importance of scale in your prompting.